Hello and welcome. In this session, I will demonstrate the use of Weld Strength Results for a number of models, which is part of the Heavy Duty Toolbox. So for this purpose, I prepared a number of models, and I will start with this model. So Weld Strength will extract the forces in each segment of a weld and calculate the utilization factor according to Eurocode 3. So this demo model here is a model with some parts that are multi-body part. We have contacts, we have weld elements and contacts, and I've already solved it. So to evaluate these weld connections, I insert a weld strength object and I select the path of the weld which I want to evaluate and a reference phase. So to do this, I find a starting edge and I can select multiple welds at the same time. I extend the selection and I apply, so 25 edges. Then I need a corresponding reference phase, so a phase connected to the section edge. So let's do the same way. Extend selection, press apply. Next, I specify what type of weld, and this is a single-sided weld. I have a weld strength, steel grade material, and the weld thickness is 3 mm in this model. And that's all. I evaluate the result, and here is my weld utilization as a contour plot along the weld section. So here we can clearly see that one corner is highly stressed with utilization over the one. And another corner here. And if I want to look on the average values, I open the solid files directory, and here I find a list of all the results, all these 25 segments. We see the on the average, we see that we have two that are clearly over one, and for each of the weld segments, we see also the maximum value for that segment. We see the radial or normal force, we see the tangential or parallel force, and we see the axial force for that segment. And the section is identified by this edge ID. So going to the model, we can select edge, click on an edge, and we can find the reference ID if we have switched on the beta features. So to show that, options, appearance, I have to switch on beta options here. So that's the first and simple case. Next, to illustrate how you may use different weld modelization, I have this demo model. Part of it is shell model, part of it is solid model, and part of it is with included welds. And again, some different types here. So we have multi-body, we have contact, we have the mesh connection defined for one. And we find here some of these are the multi-body parts, and other are using contacts. So again, I have some two load cases, one vertical and one axial. And we see that they have very similar results. There is some clear difference that the part with weld modeled have is slightly stiffer. So to do a weld evaluation here, again insert weld strength. I go on, can pick as many segments as I want. Extend the selection. And go on, select reference face. And I need to select valid, so I'm not missing any faces. So now I have at least one face for each edge, and they are connected to the weld section edges. Again, single-sided 3mm evaluate. And there we go. And by default, this was the last load step. Then I can select, if I want, the first load step. So doing the evaluation again. Or if I want, I can even take interpolation, so the mix between first and second load step. And as we see, there are slightly differences in the results. Depending on the connectivity and if you have a weld model or not, but very similar results. And again, results are available in this file. Finally, you may also have the third kind of model, a pipe model, again using contacts, surface-to-surface contact or edge-to-surface contact. And in this case, the edges are closed loops, but this will work even for this. So start selecting the weld edges. And again, selecting faces. And it's important to select the cylindrical face attached to the edge. So in this case, we actually see that there are 3 edges, but only 2 faces, but one face may have many edges. So evaluate. And in this case, I put the wrong thickness, so I will put in like 25mm. And there I go to get my results. And again, as I said, results, when we evaluate results on cylindrical welds, we open this file. As in the cylindrical system, Fx is the radial force, Fy is the tangential, and Fz is the axial force. So we here can recognize the loading we have on these segments. As remote force and remote movements, depending on then what load step we're looking at. So this is the Weld Strength utility. One final feature it has also, which I can show on one other model here again, is that you can use it for finding out the minimum weld thickness to use. So typing in 0 as thickness, evaluate, it will now iterate and propose the sizing. So in this case, 3 mm is okay most of the times, and for these corners it proposes 4 mm. So I redo the calculation with 4 mm. And it looks okay. So that's weld strength according to Eurocode 3. Thank you.